All right. Show of thumbs. You're all able to see my screen and you're all able to hear me well. I'm going to turn
Yeah.
off my video. Please use the chat and kindly mute yourself. Perfect. So let's get started. Today's session is fine-tuning large language models, how Vertex AI takes LLMs to the next level. So we have done a lot of data to generative AI applications throughout the season, right? So we have built applications using BigQuery, AlloyDB. We did
Hello.
span. Please use the chat. Kindly do not ask questions on the phone. Can you use the chat if something is bothering you? Leads, could you please mute folks in case it's coming up? The session is getting recorded, so it really help if we can use the chat for any kind of showstoppers. Is everything okay? Are we good to start? Can we get started? Use the chat to respond, please. Okay, thank you. Let's get started. So throughout the season, like I said before, we have used multiple platforms, multiple tech stacks, and multiple ways to access large language models, and in Google Cloud with Vertex AI. One thing you would have noticed is that we have used the model out of the box. Of course, we did function calling in the last session, which was a little bit integration between going out of the way to bring in conventional programming or validating the results that Gemini is responding with to make sure that the response is as expected and it is consistent across all the requirements or all the calls that we are making using that particular application. So we did do Gemini function calling, which is a little bit aligned towards a more deterministic approach. But how would you ensure that a model that is being generically designed over and trained over, even though it has been trained over several hundreds of thousands of billions of parameters, with in a generic view, in a generic perspective across all data that is available as a foundation model, which means that it works as a general purpose model for all questions or all industries. How would you expect that to work for your specific use case or a specific functionality or for a specific industry? That is always a question, right? Like there would be situations where you would say, this is fine, the response is perfect, but I wouldn't use these words. I like the way it has drafted this, but these are not my words. This blog is great, but it's not in my style. Or this report is great, this marketing email is amazing, but it has all the right words, but this is not in my style. Or there is headlines that is getting summarized from news, but it is not in alignment. It is not in alignment with the taste of the news channel. Or this has great reviews, but these were not the exact same words that the customer would have used perhaps. So on and so forth, the complaints, or not complaints per se, but you will have a personalization or customization requirements specific to your industry. Agree? We all agree with that, right? So just using the model as it is out of the box is not always sufficient. There are scenarios where you could use it, but let's say you're building an application that looks at your organization's information for tourism, or for just say railway tourism, right? So your responses or your customer support or the chatbot that answers questions related to that should be in alignment or should be in the same tone and voice as your business so far, or as your application or manual process, whatever it is that you've been doing so far. It should be in alignment with that, not just generic or not just foundational. So that is a requirement pretty much all real time or real world industry grade use cases or applications always have, that even though large language models have vast information that can perform many tasks, but they excel only when you train it specifically, special in a specialized manner for your use case, right? So that is exactly why we talk about fine tuning and LLM. So what exactly is this fine tuning? Well, as the name suggests, fine tuning is just fine tuning the model that already exists in a foundational form or structure, like taking a Gemini 1.0 Pro for that matter, or Text Bison 002, or any model for that matter, and fine tuning it for the data that you already have is what we call fine tuning. Means you are inducing a training step on top of that in order to make that model behave in a customized or personalized fashion to your needs. That's exactly what fine tuning means. As simple as that. It's just the good old English word fine tuning. That's it, just tuning it to adapt to your data set. Now, how would I do that? What are the ways we could do that? This is very much similar to your traditional machine learning methods or AI methods, if you'd like to call a supervised learning model or unsupervised problem. It is very similar to that. You also have reinforcement learning, which is human feedback based upvoting and downvoting a response, and training based on human feedback. So there are multiple ways. Today, what we're going to do is we're going to look at supervised tuning with a hands-on example. So what is supervised tuning? This improves your model by customizing it, by teaching the model to operate on your data set with a large amount of or specific amount of training data that you have collected for your industry or your use case or your application. And you would teach the large language model to respond in a way that your training data instructs it to. Right. So basically, it's a labeled data set. Just like you'd say, this is a cat. This is what I call as a cat. If it's a brown color cat, our company wouldn't call it a cat. Or if it is a yellow color something, it's possible our company does yellow color cats. I'm just saying. Just think of something else, not cat. Right? So stuff like that. So you're customizing it for your needs and you're labeling it, you're training it based on your data. It's very similar to your traditional supervised ML problem, right? The ML solution. That's what we're going to build today. And what is the use case we are going to build? And what do we need for this? We need data, of course, right? Because otherwise, a generative model is capable of answering your questions. How would you train it? How would you call it supervised training? Only when you come up with your own data on top of what the model is already capable of. And just remember that you're not changing the underlying model itself. Rather, you're training the model and you're deploying an aspect of the trained version of your model as a different separate model in itself. And you're exposing that model for your application. So basically, you have your own version of your customized foundation model. That's exactly what we're doing in supervised fine tuning. Now, what use case are we going to build today? We are going to build a headlines generation application for news articles. This one has data from BBC News Channel. Where is the data from? If you remember, several times over the course of the season and also several seasons, we've discussed that BigQuery has a lot of publicly available data that you could use for your prototyping, learning, training purposes. So we are going to use the BBC News Channel data from BigQuery. I've prepared the data, made it pre-processed it, and made it available for you to use for this use case. The link to the data is available in step 1 in introduction. If you notice, a sample JSON-L file, as you can see in my screen, the highlighted line in step 1 of the code lab. A sample JSON-L file is available for this code lab in the repository. You can upload the file to your cloud storage bucket and execute the following fine-tuning steps. So right-click on the repository, open the link in new tab. You should be able to see the data, see the whole repository, but then you will also see a train.jsonl file. Just click the train.jsonl file. You should be able to see what the data looks like. As you can see right here, this is what the data looks like. It has to adhere to certain standards for fine-tuning. It needs to have 2 fields, input text, and I think the other one is output text, right? So these field names should not change. You need to have that. One is the question or the prompt. The other one is the response from the LL or the summary of the news itself, because we already established the use case. We are going to create headlines. We are going to generate headlines using the large language model. So input text is the news itself and output text is the headlines. So basically, this is data collected from several years, over years of data from BBC, what the news and the corresponding headlines has been, so that when the model is generating headlines for new news, it will stick in tone and voice and style and format with the BBC channel's style, voice, and format and tone, right? So that is exactly what we intend to accomplish. So this is your JSON-L. And what we'll do, prepare your data. This is already done and the data set is ready for you. Fine-tune a pre-trained model. So we'll take text Python 002 today. You can also do any model that is available for fine-tuning, right? We'll use the Vertex AI SDK for Python. We'll write Python code for this. We'll evaluate the results. We'll compare the fine-tuned model response with the base model's response to see what it looks like. And we'll deploy and use your own model. Now, one thing to remember, fine-tuning itself, the process itself, if you know, when you used to do conventional machine learning solutions, you know how much time it would take for a model training to complete. So we wouldn't be able to complete the fine tuning process in this session. So I would advise you to stop at step 5, preparing and training and load training data. Step 3 is up to you. You can trigger the job at your own time later, right? So I will show the results in my end, but you will not have to go past step 5. Your result screenshot is also from step 5 itself. Why? Because step 6 and above will, I mean, of course, the credits are enough for you to go ahead and complete it, but we wouldn't be able to complete it within the scope of this session itself. But you can always view the results in my screen because I've just ran this already. Okay. So that's pretty much it. Let's get started. So before you begin, we already set up our Google Cloud Console project and everything. Billing is enabled. One more thing you have to do, since we are going to build a Python notebook for this, we'll open Collab workspace. So to create that, just if you go to step 2 before you begin section in the code lab, point 3, it says open Collab notebook and log into the same account as your current active Google Cloud account. So copy this link and go to the tab where you have Google Cloud project open, Google Cloud Console open, and that is exactly where you have to open this Collab link as well. Why? Because our project accounts, that is where you have active billing account, right? So it has to be in the same user account. That is when it will realize the project, Google Cloud project that you will invoke from this particular collaboratory. Okay, so copy that link collab.research.google.com, open it right to your Google Cloud Console. Show of thumbs, how many of you got to this point?
Abhi, your screen is stuck.
At which point?
We were still seeing that GitHub page.
On GitHub one.
Okay, that's okay. Even if it's the GitHub page, all you had to do is just open the one second. Let me show the entire screen. So what we went through after the GitHub page is one second. Okay, so after GitHub page, we just went through nothing. I was just showing the code lab. I was in step 1 and I showed the JSONL data. Step 2, go to the step 2 in code lab. That's why I asked you to keep your code lab open. Go to step 2 and in the third point in the code lab, you should be able to see open collab notebook. There's a hyperlink over there. Right click, copy that collab notebooks link and come back to your console where you have the browser where you have Google Cloud Console account open or project open, and paste that link in a new tab. It should open up to collab.research.google.com. Open that and it should use the same Gmail account that you have your Google Cloud Console project activated in. All right, we'll create a new project and we'll get started. Show of thumbs, how many of you are able to get to this point? Okay. All right. Please keep your code lab open. So copy pasting is easy. In case my screen gets froze, it's I'll make sure the instruction is clear so you're not stuck at any point. Okay. Perfect. Now go back to the code lab. As you can see right here, in step 3, I've already mentioned that it is going to use Vertex AI SDK for Python to fine tune the model. You can perform the fine tuning. There are multiple ways to do fine tuning. You can use a Java SDK. You can do it through HTTP command, curl command. You can do it through REST APIs. You can do it through console, multiple ways. Python notebook, because a lot of you have time and again asked for Python applications in our session. So this is one way that we can incorporate that as well. So we are using the Python SDK, Vertex AI SDK for Python in order to fine tune this. The full code is already available to you in the IPYNB file, the Python notebook file that is linked there in the same step. Feel free to download that and open that as well in the Collab notebook, or you can copy paste step by step as we are going forward. You can do either one, right? So either way is open, is okay. I don't understand the meaning of crab, so we have gone through this before. So if you have issues, use the chat. I don't know why that emoji is there anyway. All right, the first show of thumbs, you're all ready. Step 4, you're all ready till step 3. Still able to see my screen, all good. All right, Navigate to step 4 in the code lab. Install and import dependencies. So step 1, this is where we are going to install and import the dependencies. As you can see, we have Google Cloud AI platform, which means it tells the application that we are going to use Vertex AI. All right, and all the dependencies are there in that step. Copy this, come back to your, you can either do, in your new collab notebook, what you can do is you can either, sorry, I keep opening multiple tabs. Let me close this. Okay, so in your collab notebook, you can either do file, new notebook, right? Or you can just download the IPYNB file and you can upload it and open that one. Let me show you how to do that as well, so you're not left behind. So go to step 3, right click on the LLM Fine Tuning Supervised.ipynb file, open link in new tab. So it opens up to the GitHub repository. You can do a download right here, download raw file, right? And then go to Google Colab. I don't have space in my drive, but I'm going to show you just how you do it. Click File and do Upload Notebook, browse. Just select the notebook that you just downloaded and open. That is one way. So you don't have to copy paste the code line by line. I don't have access to do it, but you do it. Okay, I'm going to show that to you from a different account. Let me see if I'm able to. collab.research.google.com in the same account where you have your active project. And what I'm going to do is upload, browse. I'll go to downloads, LLM Fine Tuning Supervised 2. I'm going to select that. So this is what you should be able to see as well when you're uploading that file. Make sure it's open. All right. So you should be able to.
Ma'am, your screen got stuck again.
Okay. Thank you. Okay. So go ahead and upload it. Go to collab.research.google.com. If you have already downloaded the IPYNB file from the code lab, step number 3, if you see the LLM fine tuning supervised.ipynb, so right click, open in link in new tab. It should open the GitHub repository. In case you didn't see this previously, you just download this file, raw file from the GitHub repo. It should download it to your local downloads folder. And then go to collab.research.google.com, click File menu, and then go to Upload Notebook, and click Upload and select Browse, and browse for the notebook that you just created, and then click Open. And then your notebook should be ready for you to get started. Okay, so I have it ready, open right here. Make sure you're able to see this. Okay, so just explains what we went through, why we are doing model tuning, and what our objectives are in this particular pipeline, and what is the use case. Like I said, the BBC full text data, generating a title for the full text news is what we want to do today, and generating the title that is consistent or compliant with BBC's style of reporting is what we're going to do today. All right, so the first step, go ahead and run the pip install Vertex AI, so all the dependencies. And the second one, we'll import Python, wait for it to complete. Show of thumbs, how many of you are able to set up and get started, download the file and everything? Okay, perfect. Is my screen froze again?
No, Abhi.
Okay, perfect, thanks. So if you missed out the part on fine tuning, feel free to go to the code lab. Step introduction part completely explains what we just discussed. So we'll not go over it all over again because we took our own sweet time to go through the entire thing for about 7 to 10 minutes. So I think we've covered a lot. Go to step 1. It has a detailed rundown of what we have been discussing so far. All right. So while it's installing dependencies, just make sure scroll down your project ID where it says your project ID. Just go ahead and replace that, right? You need to have your project ID there, not your project ID. That's just a placeholder. Go ahead and change that. Okay. Same thing with the next one. I don't know why this was not persisted, but yeah, go ahead and change that. And then, yeah, you should be good. All right. So step one is complete for me. Moving on. Next one is very simple. Just import and do a kernel restart. Go ahead and do that as well. Your session crashed, it automatically restarts. Don't worry about it. Just wait for a sec and then go on to the next one, which is importing. Some repetitions are there, ignore that, but you can still run the other things over there. You want to authenticate your user. Go ahead and click that. Third step. So from so it is right now, if you notice, it is asking if your notebook can access your Google credentials. You go ahead and allow it. It'll ask if this email ID, the same email ID that you're using in your Google Cloud account, right? So it will ask if you can allow access to the account. I'll say continue. You should be doing the same thing with your account as well. Finally, all the other steps are done. Right now, I'm at this part which says import Vertex AI, project ID, and Vertex AI in it. Go ahead and run that and run the next one too. There are some repetitions there. Just ignore that. Go ahead and run that cell anyway. And then gcloud config set project ID. That is important because this is where you're telling the collab instance or notebook rather that you're talking to this particular project in Google Cloud, because that project is the one that has access to all the APIs and everything that we'll be using, or the SDKs that you're using to talk to the generative models. So that is important. Now, while we're doing these things, you have to have already enabled the APIs, thinking that you all have already attended the previous sessions, or maybe even if not, just take a moment to go to Google Cloud Console, search for Vertex AI in the search bar, just search for Vertex AI, Vertex space AI. You should see the one AI platform, every ML tool you need option. Click that. If you have not already enabled it, it will give you a pop-up that says enable API. Click that. This needs to be enabled in order for you to successfully continue with the collab notebook. In my case, it's already enabled. Most of you would have been enabled. For most of you, it would have been already enabled. For some of you, if this is the first time you're using Vertex AI, or if this is the first session of the season that you're attending, or it's a new project, brand new project, you will need to enable Vertex AI again, right here. It will ask you to enable all the APIs. Don't do that. Only enable Vertex AI API. That's it. Okay. Come back here. And yeah, so we have completed till this part where we have done the gcloud config set project ID. Show of thumbs, how many of you got here? So we have done nothing but just dependencies, set the environment, given your project ID. Usually these should be like environment variables which you set, configured the project, install dependencies, we did dependencies, and so forth. Is my unless the screen is froze again, use the chat. Kindly use the chat for questions. Can someone confirm the screen is visible? The screen is not froze again? Okay, perfect. All right, for all other questions, technical questions or other roadblocks, please use the chat. You may have skipped a few steps or something of that sort in case you're missing out or getting errors in one of these steps. All right, then other necessary libraries importing. So go ahead and run that step as well. Just take a look at what all libraries we are using. We've already imported Vertex AI, but it's just included several times anyway. And then we have the language models, text generation model, and then we are using evaluation text summarization spec as well. You will see shortly why we are using that. Of course, we are using Pandas library. And then what else are we using? Data sets, because we load the data set. You'll see shortly why as well. Okay. Perfect. Now moving on, prepare and load training data. So this is where we want this training data right here. You should have uploaded this in your cloud storage bucket. So currently this is not there. This is one other step. I want you all to go ahead and do it. So how to do it? Let me share those steps with you. Remember the train.jsonl file that you saw in my GitHub repository. Go to the code lab, go to step number 3. If you see, there is a repository link over there, the hyperlink on the word repository. Right click, open link in new tab. You should be able to see the entire repository. You see train.jsonl. Go ahead, go to that link. Download the raw file, right? Download this file, basically. You're downloading train.jsonl. Now what we're going to do is go to console.cloud.google.com. Let me open it in the same place where I have this. Okay. Console.cloud.google. You already have it open in one of your tabs, right beside your collab notebook, right? So just go back to the same tab. Don't have to open it again. Make sure the project is selected, the right project, the same project that you have open in your collab notebook, or the same project, the placeholder project ID that you've given here should be the project that should be visible in your dropdown. Now in the search bar, go and search for cloud storage. Go ahead and select that. You can create a new bucket, or if you already have existing bucket, go and create a folder in it if you like, or rather create a new bucket and just name it whatever you want. Let's say LLM Fine Tuning, right? LLM underscore fine underscore tuning. Click, that name is taken. So probably provide a name that works for you. LLM Tuning SSN 6, session 6, something of that sort, right? Continue. I'm going to choose region as US Central 1 because I think our LLM fine-tuning region is set to US Central 1. Yeah, select that as US Central 1. Click continue. Don't change anything else. Just go ahead and leave it as standard, not an issue. Where it says enforce public access prevention, just uncheck this for now. It will not be exposed to public anyway. It will put that enforcement anyway towards the end, but just uncheck for now since we're doing a demo. We want to make sure in case one of you has not created a link, you could use the other. But right now, let's just try unchecking this enforce public access and click create. Click the create button. You should have your bucket created. Now I see my my cloud storage bucket created. You should see these options: upload files, upload folder, create folder, transfer data. Go ahead and click upload files. You should see the recently downloaded file for train.jsonl. I think I haven't downloaded it. Let me just quickly download that one. Download raw file. Okay, done. Now I come back to upload files. I choose my train.jsonl, open, and upload has started. It will take a few seconds for the upload to complete. Yes, done. So train.jsonl upload is complete. Now go ahead and click that link and you should see the gsutil URI. Go ahead and copy the gsutil URI. If it doesn't allow you to create with the name LLM tuning underscore SSN6, use some other name. It should be okay for the most part, but if it's not, create some other name, use a different name. Click that, copy that gsutil URI and come back to your collab notebook. Okay, I'll just pause right here to do a pulse check. Show of thumbs, how many of you got to create the bucket successfully? Yes, I'll repeat the bucket creation step in a bit. Let's just show of thumbs, how many of you created the bucket? All right. So I'm going to show how to create the bucket, cloud storage bucket one more time. It will come in handy in a lot of use cases. I thought I'll upload it and make it available to public and just give you the link. But I also thought it will come in handy for you if you learn for yourself, and so you could use it in multiple projects, or you could access it programmatically. You can do anything you want to upload the file into the bucket and read it. Right now, I'm doing it manually from Cloud Console. So how am I doing it? In the same tab where you have your collab open, go ahead and open collab.research. Open Google Cloud Console. If you already have it open, just go to that open console, GCP console, and go to the search bar. Make sure you're in the same project that you're referencing in your collab notebook. In the search bar, search for cloud space storage. You should see cloud storage is the first product that shows up, which says enterprise ready object storage. Go ahead and click that. Now, you see it will naturally land you on the page, what do you call that? Dashboard page, which lists buckets if you already have buckets created. But if you have no bucket created so far, you will just see the plus create button. Go ahead and click the plus create blue button, and it should open this create a button page or configuration page, which has a tab for name your bucket, provide the name. You could say LLM tuning underscore SSN6 or something of that sort, which you can get it to create, right? Just provide a name for your bucket, anything. LLM tuning SSN6A or something like that. And then click continue. In location type, go to region, choose US-Central 1, because that is the region that we are using in our fine tuning. Click continue. Leave everything else to default values. Don't change anything else. Click create button. That's it. It will give you a pop-up that says enforce public access prevention on this bucket. Just uncheck that, because is it training project or a test project? So you can always delete the cloud storage, or you can always delete the project eventually. So just uncheck it and then click confirm. You're not enforcing public access prevention, right? So now I have my bucket created. So once the bucket is created, you will see this page where you're able to upload files, upload folder, create folder, so on and so forth. Basically, you will be directed to the objects tab. Under objects tab on the right, you should see upload files link, the blue link that says upload files. Go ahead and click that. You would have downloaded the train.jsonl from the GitHub repo, which I linked in the code lab step 3. If you go to code lab, step number 3, which says fine tune a large language model, it only has like 4 lines in that step. But if you go to the last line, the repository, the word repository is hyperlinked to the actual repository, GitHub repo. Click that and then go to train.jsonl file. And on the right, you should see, click the train.jsonl file. On the right, you will see download raw file icon, which you can see in my screen right now. Click that. It will download this file to your local downloads folder. Now come back to the tab where you are uploading files to bucket. Click upload files and choose the train.jsonl, which you just downloaded, and click open. Now the upload has started. In a couple of seconds, upload will be complete. Just like you see in my screen, you should be able to see this JSONL uploaded into your bucket as well. Go ahead and click the hyperlink that's displayed along with the name of the JSONL file. You should see the configuration details under overview section, and you will see public URL, authenticated URL, GSUtil URI. Copy the GSUtil URI. Okay, just copy to clipboard and go back to your collab notebook. That's it, right? Just copy that and keep it handy. Show of thumbs, how many of you? Yeah, that's fine. If you already have another bucket, that's totally fine. Show of thumbs, how many of you got this done? Perfect. Mamta, if you have questions, use the chat. If you've created the bucket, that's great to know. Go to the next step after import, where it says bucket name, your bucket, right? Instead of that, just provide the actual bucket name, which you provisioned there. In the URI, just paste your URI that you just copied. Take the name of the bucket from there. Just copy that and put it in the bucket name variable on top, and leave the region as US Central. Do you see what I've done here? Just the GSUtil URI, bucket name, copy just the bucket name segment from the URI and put it in the bucket name variable, US Central 1. Of course, you can fine tune the code itself, first of all. I'm just telling you what all you need to change here right now for this to work. All right, JSON URL, your bucket dot train.jsonl. Why does it say your bucket? Just replace this, what you see right here, with your bucket name. Where it says your bucket, just provide your bucket name. Storage.googleapis.com. So this is the public URL, I think. Let me see. Yeah, this is the URL for authenticated URL. That's totally fine. Just go ahead and provision that particular URL right here. Now, that's it. So this step is done. The next step is done. Go ahead and run the step, bucket name step, and also run the JSON URL step. Right now, you should be able to read it unless it says it's forbidden. Okay, that is because it is authenticated, and we have to, like I said, it is not actually preventing public access. You have to go in and make sure the public access is allowed right now, because we are not setting up we are not authenticating right here at this point again. So let's go ahead and make sure that part is removed for the public URL, right? Edit access. Go back to your bucket. If this is the issue that you're facing, go to edit access, not this one, the other one. I don't have access to this. Go to the bucket probably and edit access. Once again, let me see. Permission, not public. I want this to be public. Grant access. Oh, users. Select role, cloud. I'll tell you the step, just a second. Cloud storage. Storage, I just want storage viewer. Let's see if it's there. Okay, storage object viewer. Okay, I'll just click that. All users, storage object viewer, and save. Allow public access. So now I go back to my collab and I'll try to run this. And there we go. I got the result. So one thing that has happened is it did not let me use that. Typically, you would provide authentication to a specific user account. So when you do grant users, you will add that service account here. Instead, what I did is I just gave access to all users because I don't have a service account created right now. This is a demo application. So I gave this access to all users. So if I give this link to you right now, you should be able to do this too, but tell me if you're able to. All right, I'll give you this link. So how did I get here? I'll show you that in a bit. So you're here in this particular cloud storage bucket, right? Click your bucket name, which is whatever is your name. Just click your bucket name and make sure you're seeing this screen, which says objects, configuration, permission, protection, so on and so forth. Click the permission tab of your cloud storage bucket. Scroll down under permissions. It says view by principals. Go ahead and click grant access. Right now, it does your collab notebook does not have access to read this or view this object. So go ahead and click add principals and do all users for now. You can create a group for authenticated users, or you can create a service account and make sure only that has access. For now, I'm not taking that route. I want to focus on getting this object viewed there. So I'm going to give users to everybody. Add everyone as principal. I'm going to give everyone the role. Storage search, actually type in storage in the manage roles option. Storage object viewer. Select that and save. And it'll confirm with you. If you want to make sure that resource is public, it's fine, because I just want to make sure that the training file is available right now to your collab notebook. Now, once that is clear, just come back to this URL, this collab notebook, and just get to the cell where you have JSON URL and the data frame that reads from JSON URL and prints the data frame, basically. So go ahead and run that, and you should be able to see the data frame looking like this. So this, all we have done so far is just got the training data into your Python data frame, into a Python data frame. That's it. We have not done anything else. The next step is where there are a couple of more steps which are really important, is where we'll actually fine tune, but you wouldn't be able to complete that step in this session. So it's okay if you just trigger it and then stop and listen to everything that we're doing. But this step is important. This is what you need to submit for your screenshot. This part is right here is what you would submit for result screenshot this time. Okay. Why? Because we wouldn't be able to complete this tuning within the session. That's why this is kept as the result submission. All right, because the goal for us is to complete as much as we can within the session. Now, show of thumbs, how many of you are able to get to this point? Okay.
That file, can you give the link?
I can give the link to file. Okay. Try this. I don't know if should be all users. Let me just give you the link to the file. One sec. Try this. Yeah, it is working. So for those folks who are not able to access the JSON-L, upload the object in cloud storage, or not able to provision any permission, just use my file. I'll just ping the link and pin it so you can directly use this JSON URL. In place of JSON URL, if you have not done any of the cloud storage steps, use this link that I've pinned right now directly. Okay.
What we are trying, actually, I joined late. So you have a JSON file, and which is
Could you
your PDF.
Yeah, could you use the chat moment? You should be able to use this link. So bucket name is, so let me just highlight. This is what I've pinned. This is your JSON URL. Please use the chat for further questions, because this is accessible for all of you. You should be able to copy this link, and you should be able to put this exactly in JSON URL. And your bucket name is the middle part, the LLM underscore tuning underscore SSN 6 underscore A. This step is actually pointless, but yeah, run it anyway, because I don't know where I've used the region variable. So just run it. But we are actually we are only using the URL in this step. So yeah, this is what you need. But if you're looking for bucket name, it's this part, the one that is highlighted in my screen right now. That is the bucket name part.
Yeah.
Okay.
So all you are doing is, you have stored one file and then just reading into a data frame. That's all, right?
Correct. Use the chat going forward. Thanks, Moment.
Are we
All
getting
right, moving
rapid?
on. Gopi, please use the chat. It is, a lot of folks have completed it, so let's not take this questions in the chat. In call, we'll take the questions in the chat. Okay. All right, I'll just pause here for a moment before we move on to the fine tuning step. So for folks who have not uploaded the file into cloud storage folder, for folks who have not uploaded or not been able to give the access storage object reader access to the particular cloud storage object, you can directly use the JSON-L link which I've shared. So I'm just going to pause right here for a moment for folks who are left behind to just use that link and replace this part of the code, which is highlighted in my screen right now. I hope my screen is not froze again. So I hope you're able to see the highlighted part. This highlighted part is what I replaced with the code that I've pinned in the chat. So if you missed the link, just scroll up top to see the pinned messages. You should be able to get this link. If you haven't executed the cell that's right above it, just put the same bucket name that you see here, right after storage.googleapis.com/, right? That particular segment which says LLM underscore tuning underscore SN6 underscore A, that is the name of the bucket. Just copy the name of the bucket and put it there. All we have done so far is just prepared the training data and loaded it in the data frame. And I have already prepared the data for you from BigQuery's public data set. So we have just read it. One thing which we have done is we have enabled APIs in Google Cloud. We have made sure that this notebook is able to access your Google Cloud project, and we are able to access the large language model or anything that you're using in Google Cloud from within your Collab notebook. So that's all. We have done all the environmental setup steps so far. One step towards the code part is we have completed the reading of data, ingestion of data step, and we have just read that in a data frame. So this is the result that we currently are going to work with. This is the training data. If you see, input text contains a news blog, output text contains the summary of the news, which is the headlines for the news blog. That's it. So I'm going to go ahead and get started with the next step. Show of thumbs. All good? If your public access prevention is enforced, you should have unchecked it first. If it is not enforced, then you can do all uses. For folks who have this public access prevention enabled by someone else in your org, and you're not, that's why I said use your personal account in order to do this training course. If your org is controlling the permissions, you have to go through a service account or ask your email account to have access to that particular storage. That is exactly why we added all users. Nevertheless, I have given you a publicly available link, so you can skip all that and just focus straight on using the storage object from my link directly. All right, so that is for folks who are using some account that is being controlled by somebody else. You could have directly used the link that I shared, which is pinned also. So go back and copy that link. Moving on, just to understand the shape of the data that we have, just go ahead and do df.shape. You don't have to run it, just see it. At this point, you don't have to run any of the steps that follows. You can just watch. If you're intrigued to see what the tuning response looks like, you will not get the answer right now. You can probably wake up tomorrow and see the answer, or maybe after several hours, if you're still awake, you can see the fine-tuning results. But I'm going to show you the result from my runs from the past, so you should be able to see this. So right now, as you can see right here, the model's display name is BBC Fine-Tune model. And I'm using the text generation model. If you notice, that is one of the dependencies that we imported in the beginning from Vertex AI. And I'm using a pre-trained, that is foundational model, which is TextBison 002. This can be any other foundation model like Gemini, TextBison 001, or anything of that sort, like CodeBison, if you're training a code model, but we are not doing that. We're doing TextBison 002. That was just something that I chose at that point when I was building this project, because I just wanted to see something that's really quick, something that I could easily test and compare the results with. So I use it. As the model evolves, your response also refines and polishes with evolving models. So definitely go and try it with newer models, but this is one thing that I tried it with. Moving on. Again, this is something that you will have to define, the tune model method. Currently, there are only a few regions that support this. So stick to the regions that are available either in the documentation or that is available in the code lab. So in this case, I have defined the training data from the data frame that we have loaded right now. Right, so that is the training data that I'm passing here. And I'm providing the location as Europe West, because that is one of the supported locations. You have a link that lists the documentation link that lists all the supported locations that you can take a look at. All right, so this, once you run this, I'm not running this now. I'm not asking you to run it right now, but if you run it, it'll take several hours to complete. And once it's complete, you should see a tick mark against that, and it will say pipeline job run completed. Tuning has completed, created Vertex model, and it will give the entire product Vertex models endpoint ID, which means you have got yourself a brand new model that is created based on the foundation model that Google Cloud offers, which is TextBison 002. It's no longer just TextBison 002. It is trained on the model data that I have given as training data. We'll look at the training data in a bit, but it's nothing much. We already looked at it. It just has input text and output text. Input text is a bunch of big chunk of news data, and output text is headline data. Right, scrolling further down, predict with a newly fine-tuned model. So now that you got your fine-tuned model ready, this took about 3 to 4 hours, if I'm not wrong, or even longer than that. I don't remember exactly. But once it's completed, you will be able to run the next step, which is tuned model.predict. Remember, at this point, my tuned model still has the variable defined from the model definition right here. You won't have this variable forever. So you have to find a way to identify your model's endpoint accurately. We would have addressed that at some point in the code lab. At some point in the notebook. I'll show that to you when we get there. But for now, just know that we are invoking the model that we just deployed, just tuned, and we are invoking the predict method on the model that we just tuned. And this prompt that I'm passing, which is summarize this text to generate a title. That is it. That's my prompt. Now, this is the news bit, which I have from BBC News. Not the news from the training data, but some random new news that I gathered from the test data that I have segregated. If you notice, this is a big chunk of news that talks about airplanes, and just checking the meeting chat once to see if my screen's not frozen. Okay, perfect. The screen's not frozen. So I just come back here. All right. So ever notice how plane seats appear to be getting smaller and smaller? It's just a news article about planes and seats and how it's unhealthy or whatever, putting the passenger's life at risk, blah, blah. Right. So you have an entire chunk of news article. And my prompt is summarize this text to generate a news title. That's it. That's my prompt. And I'm invoking the predict method on the tuned model. So this is the response that I got from the model, which is shrinking space on planes, putting our health and safety in danger. This is the newly tuned model's response. Now scrolling down. Remember I told you that, is this the same model? Yeah, this is the same model, get tuned model. I'm invoking the same model, I'm getting the same result, right? This is from the same model itself, the tuned model itself. I've listed two different ways of invoking the tuned model that you already have. So this is just, these two are done so you can understand how you can instantiate that variable or how you can instantiate that object for the tuned model. That's all. Now, how would you compare it with a base model? Now you need a way to compare it against the base model so that you know the difference, right? Like what is the tone, or what is the tone that has changed after I fine-tuned, as opposed to what if I use the foundation model as it is without doing any kind of tuning. So that is what we have run right here. Base model is from pre-trained. So right now I'm invoking text Bison directly without using the fine-tuned model. And I'm calling the predict method with the same prompt. Nothing has changed in the prompt. Nothing has changed in the news article. I'm using the same news article with the same prompt and I'm printing the response text. You see, this is the response text. Shrinking space on planes, colon, putting our health and safety at risk, question mark. Now, this is what Gemini wants, or text Bison 2 wants to give as headlines. Of course, you may say that this looks more punctuated and more appealing, but that's not how BBC headlines their articles. BBC headlines their articles without punctuation, maybe. We don't know. That is exactly why it has consistently responded with the same headline or tagline for the same news article, both invocations, if you notice. Even though we have invoked the same model, the tuned model, we have invoked it in two different methods, and it has been able to get the same result in both cases, and that is how it exactly does it. Okay, so this is one thing that we wanted to go through. So you would not be able to execute the last three steps, the actual tuning, the actual prediction with the fine-tuned model. You would be able to do this step, however, pre-trained model. So go ahead and just run this one. You should be able to get the result for this one, if anything. See, I just got the result, something very similar. So you should be able to execute the last step in the model, because it is not using the tuned model, it is using existing model. So you should be able to get that result. So don't worry about the other steps. It will complete when it does. Go ahead and try it out and see the fine-tuned model result. Now, if you go to the same GitHub repository that I shared with you, just go to my account, you will see another project or another repository that says evaluation. So we are not going to cover evaluation right now, but you can just take a look at that. If you get your fine-tuning to complete, you could always look at model evaluation to see how I've used the model that we just fine-tuned and evaluated it, not just by comparing it against baseline model, but you have actually used an evaluation method to compare the evaluation, evaluation method to get the score for the fine-tuned model. So this is something that's really interesting too. We're not going to cover that in this session, but I just want to show you. I'll ping the link to this IPYNB file, the notebook file, so you can see how you can invoke a model that has already been fine-tuned and deployed. You can also see, I don't know why this is happening. Hold on. You can also see how you can evaluate a model. Okay, evaluation can happen in multiple ways. There is side-by-side comparison. There is just scoring the result by using another large language model comparison. There is RLHF based evaluation. There's multiple evaluation methods. We have done one, which is automatic evaluation. So you will not know how the evaluation score works, but it will give you the evaluation score result in the form of Rouge L sum. I don't know if I'm pronouncing it right, but this is Rouge L score is a recall based metric that measures the overlap between your fine-tuned model summary and the original reference summary. So it measures it using that, right? And it'll see what is the common subsequence between the two summaries between your model and the base model, and it'll give you what overlap it has. So just go ahead and try it out at your own time if your fine-tuning is complete. This was not part of our code lab today, but I just wanted to give you this anyway in case you're interested. Let me ping you this GitHub repository link. Show of thumbs, how many of you got the data frame to point to the data set that we have? How many of you got the foundation model to respond with the result? Okay. I think model training $5 credit should be fine. I think that should be fine. That's why I set it at $5 this season and not $1. $5 credits should be good, and it's not too much data anyway. So let's see if it completes for any of you. Just feel free to ping me on LinkedIn if you manage to complete the fine tuning, and if you manage to do the evaluation and understand the Rouge L sum score. Just keep the regions same as what I have in the code lab. It's still evolving. A lot of regions are still being made available, but the ones that are there, you will still be able to use it. So follow the repo or follow the notebook that already has those things. So I hope you enjoyed the session, and I would really be happy if some of you are able to complete this and also get to complete the evaluation step and understand it, and just let me know. But definitely there are a few things that it's not necessarily important in this notebook. There are a few times that variables or assignments have been repeated. Sometimes it's not clean. So feel free to clean the code on your own and just submit the result for the screenshot. I'm sorry, for this result screenshot for this session. So like I said before, let me just quickly show what you need to submit. Go to step 5 in the code lab. As you can see, this the last screenshot in step 5 of the code lab, which says this step should result this. So this part is exactly what you want to submit as your result for this particular session. Go ahead and submit it. I know a lot of you got the data frame to show up. So that's pretty much it. You need to learn fine tuning. Typically, mainly because all of your business applications or industry grade applications will require tuning to a certain extent. Even if not tuning, you will have to prepare examples so that your model behaves the way your application or your industry expects it to behave to the end users, or rather your customers. So this is a really important topic. As important as RAG, as important as embeddings and vector search, as important as bringing all of these three together. I know there's a lot of things to consume. We have already covered embeddings and vector search in, I think, which session we completed it? In MDM session, or it's already done, or it's coming up? I think it's coming up. Next session is that, I think. Let me quickly see. 1 second. Did we already complete? Okay, I have to open this to see that, code vipassana.dev. We have one more important topic as well. We'll use Gemma for building one RAG-based application. And we have Ivan Nardini. He's one other ML engineer as well. He'll be talking to you in the next session this season. June 20. Okay, next session is also mine. That's on Thursday. So yeah, Thursday this is the last session where you'll have to submit results in the season. The last 2 sessions that we have this season, you don't have to submit results because those are advanced concepts. And those advanced concepts, we want you to just pay attention. This is the first time we are going to be talking about Gemma on Ray, on Vertex AI. So it's a lot of new things. It's going to be conceptual, not necessarily entirely hands-on. So I want you to join in to get the awareness, get started with getting hands-on. Of course, we have a use case. Of course, there's no Code Vipassana session without having a hands-on application built, but we don't expect you to complete it or submit results. So today is the second last submission, and next session, which is on 20th June, is the last session for which you will submit results this season. The last 2 sessions on 24th and 27th are very really interesting topics. One is Gemma on Ray on Vertex AI, and the other one is RAG for multimodal RAG using Gemini Pro. So these 2 are pretty important too, apart from all the topics that we have covered. But these 2, we'll keep it at don't have to submit results. Just take it easy, learn, because we have done a lot this season. So we want you to relax and just learn. The last link that you see right here, June 28th, is self-paced. We already covered this in our first session. This is just for your awareness. If you have not covered this in the first session of the season, we had 2 code labs in the first session this season, right? So that was a bit much. So I added the second code lab to the last as a self-paced learning. We won't have specific session for this, but you can try it out at your own time and reach out and even submit results if you want. But there is no need to submit results for the last 3 sessions this season. Okay. So that's pretty much it. I'm really excited to talk to you all on Thursday, that is 20th June, for Master Data Management Simplified. The reason why this is really interesting is because we'll be talking about similarity search, which is similarity matching or nearest neighbor matching, and how you can identify duplicates in your data using generative AI. The agenda is to do nearest neighbor, that is vector search using embeddings, and not just to identify duplicates. Because with vector search and similarity matching, you could do wonders with your enterprise data. So that's exactly why we are going to address this. So I'm excited to see you all. Excited to see you all on Thursday. I hope you are all too. So go ahead and submit your results and let's chat. Use the Discord channel for any questions. Okay, if questions are not answered here. Thank you so much, and really appreciate all your support and leads. Once again, thanks a lot for consistently being there and consistently supporting. And thank you for all the repeat audience participants who have been consistent across the seasons, across sessions. It's really because of you that we are encouraged also. So I'm just going to stop presenting and stop recording. As well.